Okay, let's solve several advanced AMC problems. We'll start from the problem 19. So we have a parabola with an equation, typical equation for parabola, ax squared plus bx plus c, and it is reflected about x-axis. The parabola and its reflection are translated horizontally 5 units in opposite directions to become graphs f of x and g of x. So here, obviously, we need to make some picture just to understand what is happening. So here I draw y-axis and x-axis, and here we have some parabola. So let's assume that it looks like this, and this parabola is reflected about x-axis. So the reflected parabola will be like this one. Okay, so the orange one is initial one and the blue one is after reflection, and then both of these parabolas, they are translated 5 units in opposite directions, and they are translated horizontally along x-axis, and no one tells us here which parabola is translated where, so we will assume by ourselves that this one, initial one, is translated 5 units to the right, and this one is translated 5 units to the left, and then they become graphs f of x and g of x. So new parabola, here is this one, we will call it y equals f of x, and this one, another one, after translation, we will call it y equals g of x, right? Y equals g of x. So now we perfectly understand what is the process here, but they ask us to describe the graph f plus g of x. When you see f plus g, it always means f of x plus g of x. So basically you need to add these two parabolas, this one, and to tell something about the graph. Well, the picture here is very helpful because we understand like the process, what is actually happening. However, if you look at the graph, it's very difficult to tell precisely how to add this parabola and this parabola. And if graphic approach just allows us to understand the process, of course, we will not be able to solve the problem itself by using only this approach. We should go to algebra. And if you remember, very simple fact, what happens to the equation that describes the graph if the graph is translated, for example, 5 units to the right? If you have an equation, y equals f of x, and it describes some graph, and the graph is translated 5 units to the right, then the new equation that will describe this graph will be y equals f of x minus 5. Basically, if you translate 5 units to the right, instead of the variable x, you should substitute variable x minus 5. And if you, it's like the translation 5 to the right. And if you translate 5 units to the left, you will get the graph that is described by an equation f of x plus 5. It's for translation 5 to the left. Okay, it's along x-axis. So if you don't understand why it is the case, it's a very simple problem in math. You can consider it as a separate problem. Why it happens and why for the translation to the right, you will have this one, and for translation to the left, this one. If you translate along y-axis, everything will be very straightforward. If, for example, you translate 5 units up, then the new equation that will describe your graph translated 5 units up will be y equals f of x plus 5. And if you translate 5 units down, the new equation for graph translated 5 units down will be f of x minus 5. So this is it. It's just the basics of algebra. And here, if we have this parabola, it's very easy to understand how this parabola looks after translation. You should just substitute instead of x, x plus 5. Oh, and this is it. So, but let's start from the very beginning. Initially, we have a parabola and we reflect it. Let's understand what would be an equation of reflected parabola. In order to understand how it will look, we write the initial equation, ax squared plus bx plus c. It is an equation of this orange parabola. Reflected, it means that for any point xy, what does reflection do? So, this point is reflected about x-axis. What changes here for the point after reflection? The x-coordinate of the point stays the same, but the y-coordinate changes to the opposite. Now it's minus y. Well, if we want to reflect this graph, we use the same rule. X stays the same and y changes to be minus y. So this equation of this blue parabola will be minus y equals ax squared plus bx plus c. As simple as that. So the reflected parabola has an equation y equals minus ax squared minus bx minus c. Minus bx minus c. Perfect. It is an equation of reflected parabola, and it is an equation of our initial parabola. Now this one is translated 5 units to the right. So now we want to understand how this graph, what equation describes this graph. Obviously we need to substitute x minus 5 instead of x to get an equation that describes this one. So here y equals a, instead of x we substitute x minus 5 squared plus b x minus 5 plus c. Okay, so it is an equation for this parabola. This one is translated 5 units to the left, and in order to get equation that describes this graph, here, instead of x, we substitute x plus 5. So we will have an equation y equals minus a x minus 5, x plus 5 squared minus b x plus 5 plus c. And now we know precisely that the graph y equals f of x, so here is your form of f of x for this one, and this one is the form of g of x for this one. And now when they ask you what can you tell about this f of x plus g of x, of course you have like a clear representation, this one for f of x and this one for g of x. Now you can simply add them, and after that you will be able to tell something about their sum. So let's add 2 of these, and we will try not to make any mistakes during the process. So ax squared here, and here we will have minus ax squared, so it will cancel out. So for 2 of these, the only thing that will not cancel out is double product. Here double product, it will be minus 2 times a times x times 5, and here double product will be, again, it will be minus 2 times a times x times 5. Here minus comes from a, and here minus comes from here. And all the squares here will just cancel out. Here bx minus bx will cancel out, and here minus 5b minus 5b. So it will be minus 10b in total, and plus c, and it will be plus 2c. So this is the sum of f of x plus g of x. Let's add 2 of these. It will be minus 10ax minus 10ax. So it will be minus 20ax minus 10b plus 2c. It is the sum of f of x plus g of x. Let's look at this one. What is this function? Obviously here you can see that this is simply a number. It is a constant. It depends on b and c, but it's still a concrete number. This one, let me just separate this one. And here we have simply something multiplied by x. So here we have a form kx, k is this number, plus this constant c. So here's you have a simply the equation, it is linear equation for x, and this graph is simply a line. So it describes like a straight line on the plane, and this is it. So, and after that, let's try to answer our question. So what can we tell about this graph f plus g of x? A parabola tangent to x-axis. No, it's not a parabola, it's a line. So a parabola not tangent, b, not true, a horizontal line. Okay. Is it a horizontal line? Let's look. Horizontal line is the line that goes like this. It is parallel to x-axis. It is always have an equation y equals c, constant. If we want this one to be constant, this k should be simply equal to 0. So a should be equal to 0. But if a equals to 0, then this one is not a parabola at all. This one is simply a line if a is equal to 0, so there is no way. A is not 0 and it is not a horizontal line. A non-horizontal line, yeah, it is definitely the case. It works for us. And e, the graph of a cubic function, absolutely not the case. So D is our answer, and let's go to the next one. Okay, let's solve the second one. So we have here a polynomial of 5th degree, and we are told that the graph of this polynomial has 5 distinct x-intercepts, one of which is at 0, 0. Which of the following coefficients cannot be 0? Okay, so from the first phrase, the graph of the polynomial intersects x-axis at 5 different points, one of which is 0, 0. Immediately you should understand that this equation has 5 distinct real roots, and one of these roots is 0, 0. It's obvious because really let's draw a graph of our polynomial, and we are told that this graph passes through the origin, through the point with coordinates 0, 0. So let me draw this point, 0, 0, and also has 5 distinct x-intercepts. So besides this point, polynomial also intersects x-axis at 4 other different points. So 1, 2, 3, 4. As you can see, it is just from our initial condition. This polynomial, that the graph that we have here, it has 5 distinct x-intercepts, one of which is 0, 0. Well, as simple as that. So what is this point? For example, it has some coordinate x1. If it is a graph of a polynomial y equals p of x, what is the value of y for this x1? Well, if you see here by graph, you see if you substitute x1, the value of y that corresponds to x1 is 0. So it means that if you substitute x1 here, this value y equals p of x should be 0. x1 is the root of your polynomial. x2 is also the root of your polynomial. x3, coordinate of this point, is also the root of your polynomial, and x4 is also the root. By the way, what does it mean that the 0 is the root of your polynomial? It means that if you substitute 0 instead of x here, all of that will go to 0, and this value should be also 0. It is possible only when this coefficient e is 0. It means that we can consider our polynomial without this coefficient at all. So it means that e is 0 and we can discard it right away. Also, we know that our polynomial has these roots, and from the basics of algebra, you can understand that our polynomial can be represented like this: x minus first root times x minus second root times x minus third root times x minus fourth root and x minus fifth root, but fifth root is 0, 0, so it will be x minus 0. Just times x, because x minus 0 is simply x. So this representation of our polynomial is possible. Very important. x1, x2, x3, x4 are these numbers. These are roots. And none of these are zeros, as you can see, because these 5 points are distinct. It means that these are different points. So x1, x2, x3, x4, some non-zero numbers. And after that, when we have this basic information, they ask us which of the following coefficients cannot be 0. Which of the following coefficients cannot be 0? So e is 0, obviously. So, and which one cannot be 0? Look, if I consider this product here, so let me write it like this: x, and here x minus x1, because it's more traditional way, x minus x2, x minus x3, and x minus x4. X is a variable here, and if I expand this one, if I multiply everything, if I expand, I will get this form. So I need to understand, for example, what is the coefficient d. After expansion, d is everything that we will get near x. What coefficient will we have near x? For example, here x, I will multiply by x1, x2, x3, x4, and the only coefficient that I will have near x without any other, so x coefficient will look like x times, and it will be x1 times x2 times x3 times x4. Minus, 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 minus will give you plus. So after expansion, the main question for you, what the coefficient near the x will be? And if you look at this expression, you will figure out pretty quickly that the coefficient near x will be exactly this product. And you know that these are non-zero numbers, so this one is not 0, and there are no other terms that have x here. All the other terms will have x in some power. The only term here where you have x in the first power, if you take x from here and multiply by each of these numbers, and this coefficient is actually d. So it is actually d, and this shouldn't be 0, and therefore d is not 0. If you want to find any other coefficients, it will be a little bit more complicated. For example, x squared is, for example, the product of these two, and it will be multiplied by each of these, but you also can get x squared as a product of these two, and it will be multiplied by each of these. So you can find just step-by-step coefficients near any power of x, but we needed here only just 1 to understand that it can't be 0. So this is it. This problem is solved. Okay, and let's solve the last one. We need to find the largest possible value of this expression. So obviously, if you worked with logarithms, if you see something like this, you should write it as a difference. Log a over b should be represented as log a of a minus log a of b. This one is 1, so 1 minus log a b. Okay, obviously we can work with this one, and with this one we will do the same. Log b over a can be represented as log b of b minus log b of a, which is equal 1 minus log b of a. And now, if you need to add these two values, you will get the sum 2 minus, and here you can write it like log ab plus log ba. And you are looking to maximize this sum. You are looking to find the maximum value of this one. Obviously, in this case, if you want this one to be maximum, you should minimize this one, because it's the thing that you subtract here. However, let's look at this sum. Here you have two numbers, and if you have basic experience with logarithms, you understand that these two numbers, they are reciprocal. Really. Let's look, for example, at this one. Why is this one reciprocal to this one? For example, if this one is n, this one should be equal to 1 over n. Really, let's look at log ba. By the way, in our case, a is greater or equal than b, greater than 1. It means that if a is greater or equal than b, b should be raised to some power to get a, and this power should be greater or equal than 1, right? So, but let's designate that log ba is some number n. What does it mean? Logarithm is simply a power. What is this number? This number, or this number, is by definition a power to which b should be raised to get a. So b to the power of n equals a. If we raise now both sides to the power of 1 over n, we will get that b equals a to the power of 1 over n. So a should be raised to the power 1 over n to get b. But what is log ab? It is a power to which a should be raised to get b, just by definition. It means that it is 1 over n, just because of this one. So we started from the fact that this one is n, and we ended on the fact that it means that this one should be 1 over n. That's what we needed. So our expression that we are looking here for is 2 minus sum of two reciprocal numbers. This one is n, and this one is greater or equal than 1, because a is greater or equal than b. N, which is greater or equal than 1, plus 1 over n. We want to maximize this one. Or this one is positive, and therefore this one is also positive, and this sum of two positive numbers, obviously we are looking to find when it is as small as possible. If we make this one very small, this one will be as large as we need. If you have basic experience with inequalities, you know very well-known fact that for any positive number n plus 1 over n is always greater or equal than 2. This inequality, you can get it from the inequality from arithmetic mean and geometric mean, or you can simply tell that it is equivalent to inequality like 1 square root of n, 1 over square root of n square greater or equal than 0. If you expand it, and if you expand it, double product of this is actually 2, you will get exactly like this. It's very well-known inequality. if you have basic experience with math competitions, you obviously have seen it many times. So if you didn't, just remember. And what is the instances of this inequality? When do we have here equal sign? It's in the case when this one is exactly 0, right? So it's in the case where square root of n equals 1 over square root of n, and it is just only in the case when n is equal to 1. So when n is equal to 1, this one is equal to 2, and we have minimal value of this expression, and minimal value of this expression happens when n equals 1, and therefore minimal value of this one is 2, and 2 minus 2 is 0. It means that 0 is the maximum value of this expression, and the right answer here is 0. This is it, and this is it for today. Thank you.